Hi, everybody. My name is Andreas Triantafyllopoulos, and I'm here to present our paper on fairness and underspecification and acoustic scene classification for DCASE 2021. The way the standard acoustic scene classification problem is formulated is that we'll want to identify the scene given an audio snippet. Now, usually we want to be robust to different factors, such as the city where the data was recorded in, the specific location where the data was recorded in, or the device with which the data was recorded. And we want our system to perform equally well independent of that factor. And in our fair ASC formulation, we kind of flip that around and we ask ourselves, how well are we doing with respect to the different factors? The motivation for that is that although we obviously want to do equally well with respect to the different factors we saw before, that is often not possible due to the lack of data or due to problems in our data set. But why would fairness be important for ASC applications? Because those systems are now increasingly being used in real world applications, some of them being very critical, such as security applications or autonomous driving. And we would want all our users to get a uniform experience. Why those particular factors? That's because different social groups might live in different neighborhoods and they might use different devices. And by different social groups, we mean different people of different races and people of different socioeconomic backgrounds. Why use disaggregated evaluations? Because this is a method proposed in literature when creating a model card. Essentially, what you do in a model card is you state how well the model is working for different strata of the population. What about underspecification? For this, we ask how well do different models perform with respect to different factors. We want to see if performance of different models is different for different subpopulations. Why is this important? Because if the models show different behavior, then it means we're going to have a harder time selecting the correct model. And also the behavior to unseen populations will be harder to predict. So we will not know how well our model is going to generalize in practice. The methodology we use to measure that is to train different architectures on two different data sets, one of them being the TOT urban data set and the other being the TOT mobile data sets, which were both used on the DCASE 2018 challenge. And then we compute unitary and intersectional disaggregated evaluations. In unitary evaluations, we break down performance with respect to different single factors. And in intersectional evaluations, we break down performance with respect to multiple factors at the same time. An example of that is shown here. In the figure on the left, we break down performance with respect to the different locations. So we have 5 different models, the 5 architectures that we use in the study. And we look at the distribution of performance, which is measured as the ratio of F1 score for a given location relative to the F1 score for that particular class. And what we see here is that, first of all, that there is a variation. So there are locations that are doing far better than the average performance of the model for that class. And second, and some that are doing better. And second, that the different models show different behavior, with some models showing a much bigger variation than other models. What we see on the figure on the right, we see the intersectional analysis of that evaluation. So we see that different models show a different, so this is the performance per location, further disaggregated per city. So the different colors correspond to different cities. And what we see is, of course, again, a deviation with respect to locations, but the deviation is different for different cities. And furthermore, different models show a qualitatively different behavior across different cities. So some of them show a bigger deviation for example, for the second to last city here, whereas others show a smaller deviation and a larger deviation for other cities. This is an indication of underspecification, which is better seen here, where we show the accuracy of the different architectures with respect to the different cities in our data set. We see here, for example, that whereas some architectures show a valley, like the orange one here for Stockholm, the others don't. And where the others show a valley, for example, in Paris, the orange one doesn't. Or for example, for this part of the plot where the three architectures of the same family, so the CNN architectures used in this study, two of them show a higher performance for Stockholm than Vienna, whereas the other one shows a higher performance for Vienna than Stockholm. This is showing that even though we trained the same architectures and exactly the same data and using the same hyperparameters, they obtain different performance behavior across different cities. And as we saw in our paper, across different combinations of cities, devices, and locations. So the conclusion for that is that we do observe problems of fairness and underspecification for those data sets and the architectures we examined here. For fairness, we saw a problem with both using unitary evaluations. So the performance in some cities is better than performance in other cities, for example. But also we saw intersectional effects. So the performance of some devices is better for some cities, and the performance for other devices is better in other cities. This also shows, we also saw evidences of underspecification. So we saw that architectures show different behavior in different strata of the dataset. The next steps is to try and mitigate the fairness issue observed here using the fairness approaches that have recently been introduced, and also to further investigate the role that different inductive biases introduced by the different architectures play in underspecification. Thank you all for your attention. This was just a brief introduction to our paper, and I do hope to see you all online at the Gather Town for a more detailed discussion.